Okay, our screencast today is going to be about creating an energy model in Revit MEP. Very simple to do this. It takes only a few minutes. And I'm going to just show you how easy it is to use Revit MEP for energy modeling to do building performance analysis. Most people think it's hard, and it really isn't. Let's do this. Let's create a duplicate view of this and apply a template to it so that it's an architectural view. I prefer to work in an architectural view just because well, when we're designing a building, we're really more like an architect. First floor plan. All right, first thing we want to do is create our walls. And essentially, we can start with an 8-inch generic wall if we want, because it really doesn't matter. The point here is that you lay out the building shape and the relevant information about the building. So there we have it. Let's just check this thing real quick and make sure that we've drawn it on the right level and everything. And it's on level 1, unconnected top, all fine. So everything looks good. Okay, next thing we want to do is let's put in some interior walls. I'm going to put in just some, I'll do like a lobby over here. Let's see, what am I doing? Are we going? No, we're in select mode. Let's put in a wall. There we go. Let's go from there to maybe here to here. This is going to be like a small office building. And then we got a hallway there. And we got a hallway edge. I'm not doing this very accurately, as you can tell, but the point is not to do a beautiful building. In fact, your interior walls don't even really matter that much, except for spaces. And for that, you know, it doesn't hurt to draw them properly. I'm going to do this way. I could have just trimmed that, but this is probably easier. Okay, so, and then we need some doors. Let's put in a couple of doors. We got to get some, because we're in MEP, we don't have all these preloaded stuff in our template, most likely. So we need a single flush door for these offices. Put one here, put one there, put one there. I think that's probably a restroom or something. Doesn't really matter. And then we need an exterior door. So let's get one of those. And again, it doesn't really matter what you use here. Just grab something that is close. And the real key here is that you have the right number of doors, windows, openings. You got to have the right construction type, and that's really more important than that it looks right. Okay, and then architect. Got to keep going to that architect tab. Window, we'll go grab some windows. I just use a generic window because, again, we're not trying to make the building look right. We're just trying to get the right amount of glazing. So let's just get a fixed window. And what we're going to do here is just approximate where the windows are in this building. Now, you could draw a curtain panel if you wanted to. That's another option if you really do have a ton of windows. But for this purpose, I'm just going to say we got a bunch of windows there. We don't have any windows in the bathroom, thank goodness. We got a couple here. We got a lot along this wall. And again, placement's not important. Just get the right amount of glazing. I should say placing is not important within a wall, but you need to make sure that if like it's a west-facing window, obviously that's going to have a bigger impact in certain areas of the country than a north-facing or south-facing. So make sure you got it in the right orientation. Let's put in one more door. Do we have room for an exit door there? Oof, barely. Let's just put in a single door. Say that's our exit door. Okay, so there's that. Now the next thing we need is every building needs a floor. So let's create a floor for this thing. Let's create a structural floor. And I'm just going to pick the outside edge of the building as the edge of the floor. We've got to fix that little cleanup there. Okay, there's our floor. And then we need a ceiling. And we'll just sketch that in also. Let's just do it with lines. Let's say well, we should put a ceiling in the whole thing, but you know, ceilings do matter to energy, because you do have, you know, either you have a ceiling in a space or you don't, and that causes it to have a different volume, and your air conditioning load is different and all of that. So you do want to make sure you get your ceiling right. And I'm going to take this one down here, and let's fix that little corner right there. because we want it to be kind of accurate. There we go. There's our ceiling. It went away because it's in the ceiling plan, but we should be able to see it here. There it is. Okay, back to the first floor plan. And then finally we need a roof. Last thing is a roof for the building physical properties, and we'll have it ready to go. So here's our roof. We're going to make a flat roof, and let's just put it in here to there, to there, to there, to there, to there. Let's clean up that. Probably shouldn't have a, I wonder if that's an exterior wall there. We'll attach those to the roof. No, because those walls are only going to the ceiling. Those are partition walls. This needs to come back to here, and then I need to draw in a new 5-inch wall for the interior. That's probably not critical, but you know, it can't hurt. Oops, I meant to do this. I just changed that wall that was selected. Looks like that's it. Looks like all of those are 8-inch walls. Let's see if we can get them all. Again, this is not critical to do, but I'm just trying to be a stickler here. And I'm not going to worry about it, but this should be aligned. Oh, what the heck, I'm here. Let's align it. Sometimes I have to go. This new interface, we love it. It does kind of get a little tricky sometimes. I'm going to align that with that. There we go. Love that new interface. It is much more productive once you learn it, but if you've been a Revit guy for a while, it can be tricky. All right, let's take a look at our building in 3D. There it is. We've obviously got a problem here. These shouldn't be penetrating through the roof, so let's go ahead and grab all of them, and let's make them not go to the, just make them go to level 2. Oops, I missed one. And I left the other ones high because that might be a parapet or something. It's probably a pretty extreme parapet. So let's bring it down a little bit. So let's do 20 feet. Let's say it's 14 feet. Not really critical because it's exterior space. Okay, so there's our building. And it's pretty ready to go. Now the only other thing we need to do is we need to put spaces in the building. And spaces allow you, let me go to mechanical plan for that. Let me rename this one so we don't get confused here. Spaces allow you to put loads into a building. And loads are important, obviously, if you're doing a performance analysis. So we're going to go ahead and create some spaces. You can place them automatically, and if it's a simple building, that'll work every time. And, you know, there we go. So we got a lobby. We can name these. I'm going to call these restrooms. I'm going to call this one common. Office 1, office 2. I'm just double clicking on those. The next thing we need to do is go into these spaces and tag them with what they are. And that's kind of important because they need to be categorized by loading and what type they are. So you can see they're heating and cooled. What kind of space is it? There's all kinds of spaces you can use that have different basic occupancy type properties. So let's see if there's a here's a lobby. We use that. It's got it's got an average that you can use, and you can adjust those obviously. The construction type on these is going to be a type that you can create. The basic one has these sort of parameters, but you can go in and create your own and then go in and put whatever type you want. So we could have a flat roof with certain U values and that kind of thing. I'm just going to go with the building type for now. That's fine for now. And then all of these spaces should be occupiable, meaning you can have people in them. Another way to do this would be through a space schedule, which would allow you to set all of these at one time, and you can real quickly create a space schedule. But since there's only 4, I'm going to go ahead and just do it this way. This is a space type of an office, and what's quick about this is you get all your loads and everything based on assumptions, which is a good starting point. You can always adjust it later if you want. Occupiable and space type is office. I'll make that one enclosed. I don't even know if those have different assumptions. I didn't check, but you get the idea. One more. I don't know if there's a rest. Yeah, there we go, restrooms. And that has some basic assumptions. Now, a couple things in here, you can change these assumptions just by doing this. If I wanted to go in and say, no, there's not 3.9 people, there's 4 people, I could do that. Or my heat gain per person is 250, 250. So you don't have to use the defaults in there, but and you can do the same with plug loads. If you want to modify those lighting and power loads, you can do that. So you have the ability to change these. You can change a lot of things about these spaces if you want to get a more detailed analysis. Okay, so that's pretty good. Now the next thing we need to do is run a load on it. So we've got a building, just to review, we got an exterior wall. Did I build that as that's supposed to be an 8-inch wall, so let me just fix that real quick. Looked a little thin to my eyeball. There we go. We've got a building, we got spaces, we got a roof, ceiling, floor, walls and windows, doors. We're ready to go. So what we're going to do is hit this guy here. It's going to show us our building. I always come here and make sure I don't have any errors. No errors. Sometimes you forget a space or something doesn't bound properly. So you just want to make sure you do that. But there's our nice building. This is an office. Where do we want to build it? Let's build it in Austin, Texas. Oh, it doesn't let you type in there. Oh, not Austin, Minnesota. I do that a lot. Austin, Texas. And there we go. What kind of service do we have? What's the construction? Is it a tight, medium, or loose building? What type of report do we want? And you can get a detailed one. We're going to start with the standard one. You can play around with this on your own time. What's the ground plane? It's level 1, new place. Okay. And that's just to save it. And then I'm just going to hit calculate. And what Revit MEP is going to do is it's going to figure out where the building is, what the orientation is, what the loads are, and it's going to tell me exactly what the loads are. So here we go, 143,887 peak cooling load at July at 2 p.m. and a peak heating load of 47,000. So, and space by space, we can see exactly how many square feet and where the loads are coming from, component-wise, from each part of those buildings. So now if I'm looking at, is it worth it to replace the window in the lobby, for example? Do we have the lobby? Is that number 1? I don't remember which space. Oh, office, restroom, office 1. Okay, common. If we look down here, for example, the roof is where most of our cooling is happening. So that's where we're getting most of our heat transfer through the building. That's just great information right there. And then the other one is people. So maybe making changes to the building here isn't going to do much because people are the ones that are generating a lot of the load. But perhaps a bigger AC is needed or something else. So you can kind of find out real quickly at a glance where are the heating and cooling loads on the building being derived from, and then where should you focus your time or what have you. You can hand this to your engineer, use it as the basis for a more detailed analysis. But what I wanted to show here was how quickly you can model a building and get a very detailed load analysis that you can use as a baseline for energy and building performance analysis. Hope that's been helpful. Thanks a lot for watching.